Today we're going to talk about parallel and perpendicular lines. First, parallel lines. This graph here has three parallel lines. They all have the same gradient because they all share the same change of y over change of x. This is actually quite intuitive, so let's dive into an example straight away. A line is parallel to the line 6x plus 3y minus 2 equals 0, and it passes through the point 0, 3. Work out the equation of the line. Now, we want to compare this equation with the general form of a straight line equation, that's y equals mx plus c. We have 6x plus 3y minus 2 equals 0. We want to compare them so that we can work out the gradient and there. So that's minus 6x and the plus 2 on both sides of the equation to have 3y equals negative 6x plus 2. Then I will divide it by 3 on both sides of the equation to have y equals negative 2x plus 2 over 3. If you compare that with y equals mx plus c, you'll see that m, or the gradient, is negative 2. Because the line we are after is parallel to this line, so its gradient is also negative 2. We were also given a point on that line, that is 0, 3. We have a point, we have the gradient. We can therefore work out the equation. So let's go ahead and do that. Change of y minus 3 over change of x minus 0 is negative 2. Y minus 3 is negative 2x, y is negative 2x plus 3. That is our equation. Okay, next, let's look at perpendicular lines. If two lines are perpendicular, their gradients will have the product of negative 1. Another way to think of it would be they are the negative reciprocals of each other. Now, why is this true? Let's take a look. I'll draw a line here and call that line 1. Now, what is the gradient of line 1? It's change of y over change of x. Okay, so let's call it A here for change of y and B here for change of x. Therefore, it's A over B. Now, I'm going to rotate this line 90 degrees anti-clockwise. And I'll call that line 2. Well, remember, I rotated it 90 degrees. So that means line 2 is perpendicular to line 1. What is the gradient of line 2? Okay, it's also change of y over change of x. Okay, let's rotate A and B also 90 degrees. So A is here, B is here. Okay, change of y, it's B here. But you see it's going down, so it's actually negative B. Change of x, it's going right, so it's still positive. Alright, so that's A. If we multiply the two gradients together, we get A over B times negative B over A, and that is negative 1. Or another way to think of it would be they are the negative reciprocals of each other. Okay, let's take a look at an example. A line is perpendicular to the line 2y minus x minus 8 equals 0 and passes through the point 5, negative 7, find the equation of the line. Okay, we want to compare this equation with our general form of a straight line equation, that is y equals mx plus c. We have 2y minus x minus 8 equals 0. So let's add x and 8 on both sides of the equation to have 2y equals x plus 8. Next, we'll divide by 2 on both sides of the equation to have y equals half x plus 4. If you compare this with the general form, you see that n, the gradient, is 1 over 2. Okay, the gradient is 1 over 2. The line we are after is perpendicular to this line. So it means the gradient of that line is the negative reciprocal of 1 over 2. And that is negative 2. We were also given a point on that line. 5, negative 7, we have a point, we have the gradient, we can therefore work out the equation. So change of y, that is y minus negative 7, over change of x, that is x minus 5, is negative 2. Let's tidy it up. Y plus 7 is negative 2x plus 10. Therefore, y is negative 2x plus 3. That is our equation. Okay, so this is the end of parallel and the perpendicular lines. As always, I will give you homework. Please try it, and I will go over homework in our next video.